concepts of centripetal force and centrifugal force are fundamental in mechanics when studied the dynamics of curvilinear motion.
Hello, sweethearts. Today I come to tell you that last night I was driving my car, and on one of those curves, I turned it so that I collided with the car door. I almost broke flower pot since I was not wearing a seatbelt. I stopped to think about why that happened, and well, I look investigated because I'm curious, like Curious George, but I am not a monkey, and well, I saw that I do to centripetal force.
Let's should remember that Newton's first law says that every body maintains a state of rectilinear and uniform motion as long as no force acts on it. Since circular motion is not rectilinear, although it may be uniform in speed, we see that there has to be a force to not contradict Newton, right?
And knobs. You may ask, what's centripetal force? Well, I know. Whenever a point mass describes a curved path, there is a force acting on it, even if the speed module is constant. This force is what we call centripetal force, which means towards the center. In short, imagine that there is something in the center, something that supports another thing that moves, but it moves around this thing, because that things that support the other things make that thing moves, not move upwards. Revolve around the central thing, the centripetal force is that keeps in a circular path.
I will show you another example where the centripetal force is applied. To express this idea more precisely, we need to research the language of math, and now let's take a look. This is the formula of centripetal force. The F with the letter C obviously represents the centripetal force, the M is the mass, the V is the velocity, and the R is the radius.
Another example of the centripetal force is the spin of a children's game in which the force is focused on the steering wheel to drive the spin.